Okay, welcome to the most popularly requested problem on the review, number 4. So the biggest thing about number 4 is kids don't really know exactly what's being asked. So I'm going to try to help you with that. If I said to you there was a function f of x and that was equal to, hold on a quick second. Okay, whoops. And that was equal to x squared. And then I said to you, let's shift this down 3. I hope you would take this right here and you would shift it down 3 by just minusing 3 on the back end. Well, that's what this first one is saying. Instead of a specific parent function, we're saying, hey, here's the graph. Now you take the graph and you take the function minus 3. That just means we're going to shift the graph down 3. So every point on here will be shifted down 3. Well, if we get our key points, we should be able to connect and make the graph. So over 2 up 2 is a point. Well, if I shift this point right here down 3, 1, 2, 3, it's going to be at 2, negative 1. So on this graph here, I've got 2, negative 1. And likewise, negative 2, 2 will be at negative 2, negative 1 if I shift it down there. Sorry, I forgot to make it an open circle. So then I make that an open circle here, and that is the first part of the graph. Okay, now obviously I can go and I can do that with the other points, or I can just determine recognition of where these are in relation to each other. From this end point here, we're down 1, 2, 3, 4. So from here we're going to be down 1, 2, 3, 4. So I'll have an open circle there, and I'll be able to make the rest of that part of the graph. Okay, and likewise from here we're down 1, 2, 3, 4, 5. So from here, 1, 2, 3, 4, 5, or one level lower than the other one there. Okay, so basically shift it down 3. Now this one here, shift it right 5. When I'm saying it, I'm just saying the function. So take the entire function and pretend we could animate this and literally see this all shifted to the right 5. So the point 2, 2 is going to be 1, 2, 3, 4, 5, 6, 7, 2. Because again, this point will move to the right 5. All right, and this is 1, 2, 3, 4 long. So 1, 2, 3, and then an open circle there. All right, and essentially we're doing that to every point. So once again, since I know that there's 1, 2, 3, 4, 1, 2, 3, 4, I can kind of go fast there. And then basically down 1 over 1, 2, 3, 4 from there. So down 1 over 1, 2, 3, 4 from there. And we can finish our graph. Everything was shifted to the right 5. Okay, so now what I'm actually going to do here for the video is I want to be able to see this graph originally. So I'm going to talk about the rest of these, but the problem is if I move this, as you can see down here, we won't be able to see the original function. So I'm going to talk about this one first right here. Let me get that in green here. So I'm going to talk about this right up here, and I just want to talk about what's happening to each point. So this says 1/2 of the function. So this would be 1/2 x squared. Well, this is the a value here. And anytime we have an a value, really study your notes here, a value less than 1, that's going to be a compression. So just take one point. I know it's challenging to think about this whole graph, but take one point at a time. If I go over 2, normally I'm going up 2. So now for this one right here, what I'm going to end up doing is going only up 1. Over 2, up 1, because over 2, up 2 was what I normally did. Same thing here. I normally vertically go up 2, so I'm only up 1. And why is that? Sorry about that. Back it up again. Got that open circle, okay? But that's because I'm vertically compressing what I normally do. So that would be like so. Same here. I normally go down 2, so now I'm only going to go for all of these points down 1. Normally I'm down 3, so now I'm only going to go down 1.5. This is challenging to show on here, but hopefully that makes sense. So again, that's the vertical stretch or compression. All right, this next part. So let me back off of that, and I'll do this in a different color. So this next part in blue here is the same thing as saying f of 1/2 x. Okay, well what's that do? That's the b value. The b is 1/2. So what we're doing is a horizontal stretch or compression. Okay, now this is bizarro world. So the fraction in the A land here makes it a compression. Whereas if this said 2 times the function of x right here, this would be a vertical stretch. Well, in here, when it's a fraction, it's actually called a horizontal stretch. So this has a stretch factor of 1/2. Okay, well, how would I do this? Well, normally, to get to this point right here, it takes me 2 to get up to. But I'm going to change the horizontal so that I'm stretching it. So it's going to take me twice as many x values to get up to a level of 2. So this one here, it normally takes me left 2 to get up to. Now it's going to take me left 2, 3, 4 to get up to. And obviously everything in between there is still going to be on the graph. All right, so once again, if this were here, let me just kind of show you if it was like this 2 in here would actually double the x value, would mean that I'm actually entering in stuff that's bigger, faster, so I'm going to get up faster. So it really compresses. So when we have a fraction, it actually stretches it. It's a little tricky. Continue to work with it. We will continue to give you problems with that throughout the semester. So likewise, normally I go over 2 and I'm down 2. Okay? Well, now if I'm stretching this out here to get over 2, down 2, what would that look like? Well, we could do that, or we could think about like, well, we know in relation to this point, and this is where it's going to overlap a little bit, in relation to this point, doesn't it have to be the open circle right below it, right? And then we're going to stretch this out here. Whoa, didn't mean to do that. Hold on. Okay. We're going to stretch this out in our graph. See, this is going to be challenging here because the graph's a little smaller up here, but that's okay. So we're going to go right here, and we're going to stretch this 1, 2, 3, 4 over to this point here. Now, how am I doing that? Once again, see this dot at 2, -2? Well, it's not going to be at 2, -2 now. It's going to be at 4, -2. And this one right here on the original function that was at 4, -2 is now going to be at 8, -2, and it's just stretching that all out. Okay, and likewise, off of the end of this one right here, if we go down, we would be here for that point, because 1 left 2, down 3 is actually going to be left 4, down 3. And this on the original function was left 1, 2, 3, 4, down 3 is now going to be 8, down 3. So it's going to look like that. Okay, so this stretches it out, and that's a little bit tricky. I get it at first. Okay, so let me erase that graph now. Hopefully this is helping a little bit. It doesn't have to be perfect, or it's not meant to be perfect, but I hope it's helping a little bit. Now I'm going to do the 1 minus the function up on top here. Let me go back to, let me go to green here. So if I did 1 minus f of x, well, another way to think about that would be the opposite of the function plus 1. Okay, so what's that mean? Well, I know you guys know that means a vertical shift, so we're going to go up 1, and then we're going to flip it, basically. Okay, well, this can get a little tricky with this one because this isn't a function you're used to graphing. Now, if I would have said to you guys, hey, why don't you take the opposite of x squared and add 1? I'm pretty sure all of you would go, oh, that means go up 1 and then go like this. Now, one thing I want you to notice about there is that you actually reflected that vertically about this line, which in this case would be y equals 1. The reason you did that is because you shifted up 1 and then you just flipped it. But what you did not do is you did not shift it up 1 and then reflect over the x-axis. You reflected over the new, quote, new x-axis, unquote. Okay, so basically you can go ahead and shift it up 1, that's fine, but when you reflect it, it's just a vertical reflection over where you kind of have your new axis to, all right? The other thing you can do, which is probably the easier one in my opinion for these, is you can actually do the reflection and then you can do the transformation. Okay, I think that might be easier for these. So if I do the reflection, like think about this one. If I would have started with a normal, let me get a different color here. If I would have started with this normal one here, okay, I could have first reflected it like this and then shifted it up 1 to get it to the parabola there. But that's not what you guys typically do, but I think it's actually easier to do the reflection and then transformation when you do these. So let's just think about that. You know, I'm going to take this yellow marker here, and this point right here, like where's this going to go? Well, this one is going to, if we reflect it right away, that would be 1, 2, 1, 2. That would be right here, but then when I shift it up 1, it's going to go right there. Same with, if I take red now, this one, okay, this open circle here. If I 1, 2, 1, 2, and then shift it up 1, that would be right there. Now, not to, well, and then, okay, so then we would go, man, what a great job, Powell. I keep forgetting to make an open circle. I apologize. All right, so there we go. So this is the way that one would look. Now, let's say we didn't want to reflect it and we actually wanted to shift it up 1. Well, remember, you're reflecting over this line then. So if this point goes up 1, it would be right here. And then it would be 2 away from this line, and then 2 away would put me right down there. All right, so I hope, you know, with this explanation that's making a little bit of sense. But that's how you would do that. So now this one, if I reflected it, we can do this with the reflection and then the add 1. This reflected would be 1, 2, 1, 2, and then when we add 1, it would be right up there. So obviously this one would be there. And then this one right here would be 1, 2, 3, 1, 2, 3, and then up 1 right there, and it would look like so. So the red graph here would be the way that looks, and obviously verify that on the online solutions as well. Okay, that was intense. That was a little bit of the crazy one there to talk about, but it was still fun math. So moving along down here, this last one is 1 minus x. Now, to do this one, and I'm running out of room up there, so I just want to talk about it like this. This is about as tricky as we can give you on the inside there. You can think about it like this, for sure, but you can't move it left, right until we're in the form, basically like x minus c on the inside there. So basically the function, we want to pull out a -1, and then we got to have it be x minus 1 on the inside there. Well, what that means is, and you can explore this, and we've done this in class, but it means you're going to shift it right 1. A lot of you would have said left 1 because of the plus sign there, but we actually have to factor out the -1, move it right, and flip it horizontally, okay? So move it right 1, flip it horizontally. Move it right 1, flip it horizontally. So just follow some ordered pairs here. Do this in blue. So this one right here, move it right 1, flip it horizontally. Well, again, it might be easier for you to flip it horizontally, 1, 2, 1, 2, and then move it right 1. That might be easier for you. I'm not sure, okay? I think on these, with these horizontal line segments, it might be. If you want to, you can move it right 1. That's totally fine. But then when you flip it horizontally, you got to think about where is the origin. Well, the origin to this problem is right here. Would you agree with that? When we move it right 1, this is the line that you have to reflect over, right there. So if I move this point right 1, that's fine, but now I'm 1, 2, 1, 2. If I move this open circle right 1, that's great, but now I must reflect it in this line, which gets me to right there, which is going to be that graph right there. Okay? So again, I'll do these either way. I can move it right 1. I can move this point right 1. That's fine. So I move it right here. But then I'm reflecting in this line. I can move this point right 1, but then I'm reflecting 1, 2, 3, 4, 1, 2, 3, 4 in that dashed line, x equals 1 there. Now, if you want to flip it, that's totally fine. So take this and flip it right away. But if you flip it right away, you do it over the y-axis. So this goes 1, 2, 1, 2, and then we have to slide it to the right one after that. So this will go 1, 2, 3, 4, 1, 2, 3, 4, and then you slide it to the right one after that. Okay, so I hope this video helped clear up some of those misconceptions.